We're going to talk about nodes now. This chapter is all about nodes, introduction to nodes. Why do we use them? How do we connect them? And what are they doing for us? And why are we working in a node-based system? So why don't we talk first about this main object context? I'm going to place a couple of these primitive objects here. I'm going to use the tab menu. As you see here, we have our nice indicator here. Please press tab to add nodes. So you press tab and we have a whole bunch of options in here. You can always search for what you want just by going through the various folders in here. But if you know what you want, you can just type it. So I would like a sphere, so I'm going to type the word sphere and I'm going to place a sphere down. And I would like a box, so I'm going to press tab and type the word box. And I would like a torus. All right, so I have a sphere, a box, and a torus. I'm going to move them away from each other. So I'll select the box and I'll move that one way. And I'll select the torus and I will move that the other way. All right. So we have three nodes. Each node represents something in the scene. We talked a little bit before about the node type, and you'll notice when I select each of these, this tells me the node type. It is the exact same type. A geometry node is your basic type of node for having geometry come out of it. Essentially what it does is it just gives you transformation information, render properties, and miscellaneous display of viewport stuff. I can make an empty node just by typing geometry in here. And you'll see when I disable these, what I have is an empty node. It's geometry. It has all the exact same stuff you'll see on the outside, same type as geometry. If I highlight it and press enter to dive inside, it is an empty node. There's nothing inside of it. So when you do these things like putting down a sphere, a torus, etc., all it is saying is put down a geometry node and then inside add this other operator in here that will output what I'm asking you to. So in this instance, it's a box. In this instance, it's a torus. And in this instance, it is a sphere that's being output. Inside the geometry objects here, we are in a different context. It's not labeled here, it just says geometry. Well, that is the label as opposed to objects, but this is more commonly known as SOPs. So the SOP context is where you build up geometry. So here, for instance, we can put down something else. I'm going to type the word test and we'll put down a test geometry of Tommy. And I love Tommy, but I think he needs a friend. So I am going to go back to test geometry and give him a rubber toy friend. And I'm going to type merge, which allows me to take these two pieces of geometry and output both of them together. I do not like our rubber toy being so big and being all on top of Tommy. So I'm going to put a transform node here, put that in between and move him over here, move him up, and scale him down. And when I go back up here, you'll see that what we've done is we've changed what the output of this node is. This is now outputting this network. Network being built up of nodes connected to each other and outputting something. And don't worry about all the connection stuff. We'll get into that very, very soon. So now I have our Tommy and rubber toy geometry object, and I can move them around up here. And you'll notice that the transformation here basically says this thing is a container. Anything inside of it is going to be transformed. I will reset that, and I will turn this on and off. Now you'll notice that I was using this for display, and you'll see we have two different things here, as well as this icon set here with an eye, and we'll talk about this right now. This is the display information. So is the object on or off, displayed or not displayed? And here is the selection toggle here. So if I deselect that, that means box cannot be selected. I can try and it won't select. I'll window over everything and you'll see we select these two, indicated by the yellow outline, but box is not selected at all. Now that's very different than what happens inside here. So in here, if I enable Tommy and I dive up one level and I turn him on, you'll see that only Tommy is output here because that's his flag. We call these visibility flags. His visibility flag is set to on. If I go to rubber toy and I enable the transform, you'll see that the rubber toy is the only thing that's output here. If I go up here, then we're not even seeing the effects of the transform. We just see the rubber toy being output here. And if I enable my visibility flag down here, then this entire network is showing up. So I did talk briefly about this, and you'll notice that, and I did say we'd come back to it, and this is the time. You'll notice now that we're inside this network, and we see that the objects outside the network are grayed out. They're ghosted. And that's because of this button here. I can choose this to hide everything that's outside of this network, which is very useful. A lot of times you don't want to know what's happening outside. You just want to focus on what's inside. You can ghost the objects outside, or you can make them fully visible. So this is what this option does for us. And here we'll just choose ghost. So speaking about these flags here, you have this yellow flag, which is going to be on the very right side, and that is our disable flag. So even though we're viewing this, what we can see is the node for Tommy here that creates him is disabled and is no longer functioning. Our transform is disabled. So this is useful for connecting things in the network, turning them on and off to test whether you like them or don't like them, or see what's happening here. The I button here will bring up information about what's happening in your network. So we won't get into all this, just know that it will give you some information about that. You have this, for this now, I'm going to choose hide and I'm going to go to my transform. You have an option here, which is called a template. And it might be easier to look at it in Tommy here. So I'm going to do it like that. What template does is it says, even though I'm looking at this, I still need to know about this other thing here because maybe this is a component, maybe it's a steering wheel and this is the rest of the car. And I need to know how to place it appropriately, but how can I do that unless I'm merging everything together and seeing the results together? Well, this lets you get a different styled preview of something else coming into the network. It's called a template, and that's what the pink flag does. You can have multiple things templated. So I will put down another test object. We will use the squab in here, and I am going to shift and select that here. And now you'll see that we have both objects templated. So you can template multiple things. If I just click back on template here, it will enable only Tommy and this squab we no longer need. Now, if you would like your template to look different, you can select the D key and you can go into your markers tab here and set the option for template model geometry. And this is where this controls how that looks. So if I wanted that to, we'll say flat shaded, now Tommy is flat shaded. He's ghosted. I can unghost him. So that's where you control how your template objects look. And this button here is a lock button. So what a lock button does is it says, I don't care about what's happening, about anything above me. I am basically storing the results in the Houdini file. I am going to write this in your Houdini file. It can be very dangerous to use this lock button because if something has changed in the network above, then it's not going to be reflected here. So I will put down a transform here, just merge it right in the middle, and we'll say, okay, we've moved test object over here, right? However, when I go to that lock button, this doesn't show up at all. In fact, I'm going to press the Y key here, and I'm going to slice through that network. I can even disable this node, and guess what? He's still here, which is crazy because this is just a transformation node. It doesn't know anything about what's happening here. but the lock stores all that information in here, and that will write to your Houdini file. I would generally recommend not using this unless you have a very good reason. But for the most part, what you would want to do is actually write this data out onto disk as a file and then read that back in instead of locking it. So I will unlock it. It's going to discard, and it's broken because we don't have our connection again. So I'm going to connect that back up. And that should cover most of this. Now, while we're in this network here, I'll show a special node, which is called an output. So I'm going to put an output here. And what an output node does is it says, I don't care about what you're looking at. Whatever you are viewing when you're inside the node, it doesn't matter because whatever is connected in here is what I'm going to output. So I'll connect that to our test geometry. And even though we're not looking at this node, when I dive up, you see it only shows us this rubber toy. And that's because that's where the output is connected. If I change this to Tommy, and I go up, only Tommy is output here. So that can be very, very useful for maybe you're working in here and you're doing a bunch of changes, but you want to make sure you don't accidentally leave the wrong thing visible, right? If I'm supposed to be looking at both of these, but instead I'm working on my part of my network here that's controlling the rubber toy, I dive out. Oh no, what did I do? That's not what I want. I want to actually be seeing both of these, right? So there you go. That's how that works. And you can have multiple outputs. So I can say up here is an output for Tommy. And then here is a secondary output, which I'm going to make sure it's set at a different number. And that will output this. Although in this context, it doesn't make any sense because you can only output one geometry. It would make sense if this was a subnetwork. And I'll kind of show that here. I'm going to take these and I'm going to click this button. That will bury everything into a subnetwork. I go inside. Now we have a subnetwork and you'll see there's an output, which is outputting Tommy in there. Now from here, I will make another output node, output index 1, and I will set that to our rubber toy. And now you'll see we got two outputs here. However, when I click here, it will only show us our default output, which is output number 0, which is number 1. Actually, it's indexed at 0. And if I wanted to see both of those things together, I could just merge both outputs together. Now I have both of those, right? So outputs can be really useful for using subnetworks and generating different ports that go out. All right, so talking about ports, they have different meanings in the object context versus the SOP context. And I'll show you what I mean. If I connect, and the way you connect is you just drag from the bottom into the top. If I connect this sphere to the box and I connect the box to the torus, well, something interesting happened there. And I'll show you what that was and what that's all about. First, I'm going to disconnect this. In this context, what this means is make a parent-child relationship. This node isn't actually doing anything to these other than giving it transformation information. So right now, this box is a child of the sphere. That means if I take the sphere and I move it, and I rotate it, or scale it, the box is going to move along with the sphere. We call it a parent-child relationship. I'm going to undo all of that stuff. Now, what happens to the torus? Why did it suddenly snap here when I connected it to the box? The reason is this box has transformation information written on it, as opposed to the sphere, which is sitting at our world space of 0. And these values are relative to the parent, whatever it is parented to. So right now, this torus is parented to the world. meaning that this is an offset. You can think of it as an offset from the world space. So we're offset negative 1.4 units from our world. However, if I get parented to the box, which already has a transformation on it, what happens is we are offset from this value instead. We're not offset from the world. I go here, and now it's maintaining this distance as if the box were at 0 and then shifted over, right? Well, that might not be how you want this to work. So we'll disconnect that again and just notice that there is this option here that says keep position when parenting. If you toggle that on and now you connect it, the torus doesn't move. Now, if I move this sphere, you'll see that everything is parented to that. And additionally, I can move the box, and only the torus, being the child of the box, will move. And finally, I can move the torus wherever it is that I need. Now, you'll notice that these values, they don't reflect the new value. It hasn't changed. So we can actually choose the extract pre-transform, which actually might keep it the same, or reset the pre-transform. But yes, there's no difference in here. If you're used to animation and you understand the transformations that are hidden by some of this stuff, that will make a little bit more sense, but it's not important to understand this just yet. This is really interesting because you have a child compensation toggle here. I'm going to disable that, and I'll show you what this means. Right now, if I move this sphere, everything moves along with it. Sometimes you don't want that if you're making just an adjustment and you're not doing animation. So if you click this child compensation button on and I move the sphere, you'll see that none of the children move, which is really useful. So you can reposition the sphere where you need it and then turn off child compensation. And now everything is back to how you want it to be. Now, this is very different than how nodes work in this context here, in this SOP network. In the SOP network, if I parent things together, I'm not actually parenting. I am creating a relationship. I am simply saying the output of one node feeds into the output of another node, which does a thing. And we saw that here. So if I do the test object, and for this time, we will put down Mr. Pig. I'm going to put down a mountain SOP here. So what the mountain SOP does is it just does a little noisy displacement on our pig geo. So it's a parent-child relationship in the sense that you start here and then you end here, but it's not passing transformation down. It's actually passing down point and attribute data, and whatever's connected is acting on the data that's incoming. So you can think of these all as little components, little pieces of a puzzle that all do something, or pieces of a network, right, that work in succession. So you start here, you do this thing, and then maybe I transform that. Oops, we'll transform it this way. And then maybe I color the pig red, but not everything in here. So I will just select some parts here. Maybe those pieces get colored red. And what you're building is a network that does stuff. It's different than this transformation parent-child relationship. So you can think of this as a builder context, and you can think of this more as a traditional hierarchy like you might see in a 3D network. You'll also notice that you have a tree view here, which can show you what's happening in your networks here, but it doesn't show the parent-child hierarchy relationship, unfortunately. All right, so let's talk about connecting and disconnecting nodes. We'll go inside here, and let's say we did not like this mountain. So I can move it off to the side, and I can just bypass that by connecting that way. I can disconnect it by pressing delete, selecting the actual connection and hitting delete. Or you have a really fun Houdiniism way to do it, which is to grab the node and shake it left to right. Shake, shake, shake. and it disconnects. You'll see a lot of shaking because it's a kind of nice way to disconnect objects without having to manually reconnect stuff. So really, really great. When we're merging stuff together, so we'll select merge, we'll do another test object, this time template head. Oh, he's so small. Let's make him a bit bigger. You can drag one by one. Or if you have a lot of things to merge together, you can simply select everything that you want to merge and just drag one of the ports, and you'll see you'll get all of them coming with you, and you can merge together. You have ways of changing the style of these networks. If you hold down Shift S, you're going to change the connections, whether it's straight lines or these curved lines. I really like this curve view. Personally, I find it to be very pleasing and easy to look at. You can also hold down the, I'm on Windows here, it's the Alt key, and you can click on a line, and now you have a little placeholder connector that you can use to rearrange your nodes in here. You can organize things by grabbing them, and you can put them into a network box. So now all these things belong to the same box. If you want to add something to the box, you can put a transform node here. I'll just wire this in here. You can wire in just by dragging on top of the wire. That inserts it right there. But let me kind of undo that for a second. So when I put it in here, it's not actually, or shouldn't be part of that box, but maybe it is because I created it outside and dragged it in. Let's try a new one. So I'm going to transform it. Oh, it is adding to the box automatically. Okay, great. Usually when you drag things in here, it adds it to the box, your network box. Sometimes it doesn't. If it's not actually in the box, you might see it grayed out, for instance, looking like that. And it can be a little confusing. All you need to do to put it into your network box is just move it around a little bit, and it should automatically add in. These are really useful because you can use them to describe what's happening. So make stuff. And then you can fold them up if you don't really want to see that. You can press the C key, which will bring up color options here, and color those for your own use. Coloring nodes is great. It's a great organizational tool. And I recommend when you're building networks, you think about color coding things. A lot of times I will do important nodes or nodes that control something in a specific color. So for me, I usually use this kind of seafoam color here. Then when I'm looking at a network, say from this far out, and I'm saying, well, what are the things that control the useful parameters? Yes, anything that's that color. You can also change your node shapes in here. So you have tools for doing that. You can click this button if you want, and mine is very small here, but that's okay. You can change the various styles. These are also really useful for organizing your networks. Laying out the networks is really important. So let's say everything is kind of willy-nilly here, right? You can kind of manually move things around. You can feel them snap into place, or you can do the shortcut. You can select the nodes you want, hold down the A key, and then if I drag down, it will line just those nodes up vertically, which is really nice. If I hold to the right, it'll line them up horizontally. So that's very useful for organizing. If everything is just a mess everywhere, you can just press the letter L, which will neatly lay out your network. Seems to be okay with this stuff there. I don't know why. To me, that's not cool, but I think because they're in the node box. So let's drag everything out of the node box. I'm going to undo that. Dragged a little too hard. Grab that little guy. All right, delete the node box. That's not the node box. Try one more time. All right, now press L, and now everything lays out like it should. Now, if you are way off here and everything's kind of disappeared, you can press the H key, which will home you in to your network. In case you're not aware, by the way, of how I'm moving around networks and stuff, I'm holding the middle mouse button and I am dragging left and right, up and down, and the right mouse button for zooming in and out. And that's kind of what you need to know about connecting nodes and disconnecting them, right? Things are just ports coming out and ports coming in, and sometimes there's certain kinds of data that are being expected, and what you're doing is just building relationships between things. And when we get into the next chapter, we will actually start working a little bit more with building out a network and understanding how to make things relate to other things in the network.